วันนี้ก็เป็นเหมือนเช่นเคยครับทิปโก้แอสฟัลต์จำกัดมหาชนเราก็พยายามจะมีอะไรที่เป็นเรื่องใหม่ๆแนวทางเข้ามาเพื่อนำเสนอแลกเปลี่ยนนะครับทางด้านวิชาการงานทางนะครับสำหรับในปีนี้เนี่ยนะครับผมขออนุญาตที่จะนำเรียนในรูปแบบที่อาจจะดูเป็นเรื่องที่ค่อนข้างจะไกลกับสถานการณ์ปัจจุบันแต่เพียงแต่ว่าสิ่งที่เราจะเจอในอนาคตเนี่ยแน่นอนว่ามันมีความเป็นไปได้ที่เราต้องปรับเปลี่ยนนะครับคงได้ยินเรื่องของโลกร้อนเรื่องของการลดอุณหภูมิเรื่องของการใช้ทรัพยากรสิ่งเหล่านี้นี่เป็นเรื่องของสิ่งที่เทรนด์ของในโลกปัจจุบันมีค่อนข้างมากเพราะฉะนั้นแน่นอนว่าในเรื่องของการปูถนนหรือปูแอสฟัลติกคอนกรีตหรือทำถนนเนี่ยมันก็จะมีสิ่งเหล่านี้เข้ามานะครับวันนี้ทิปโก้แอสฟัลต์เราขออนุญาตที่จะนำเรียนในเรื่องของเทคโนโลยีของผลิตภัณฑ์แอสฟัลต์แล้วก็เทคโนโลยีในการทำถนนนะครับเรามีแนวทางที่นำเสนอในวันนี้อยู่ถึง3แนวทางนะครับอันแรกก็คือเรื่องของการที่จะพูดง่ายคือเราต้องลดการใช้ยางมะตอยในแง่ของเขาเรียกว่าคาร์บอนนะครับซึ่งเป็นสารที่มีเป็นปริมาณที่เป็นส่วนใหญ่ของยางมะตอยเราต้องการที่จะลดตรงนี้ลงนะครับมีแนวทางยังไงในการที่จะลดพูดง่ายคือลด sensitivity ของตัวคาร์บอนในแอสฟัลต์ในบิทูเมนอันนี้ก็จะมานำเสนอนะครับอันที่2คือคงพูดในเรื่องของการที่เราต้องลดผลกระทบด้านสิ่งแวดล้อมนะครับอันนี้ก็จะนำเรียนในเรื่องของเทคโนโลยีของการทำเป็นฟาติคอนกรีตที่เป็นลักษณะของวอลแมสฟัลนะครับรวมไปถึงการพัฒนาผิวทางในการที่เราทำไปถึงระดับผสมเย็นหรือโคแอสฟัลนะครับแล้วก็สุดท้ายเนี่ยนำเรียนในเรื่องของการสนับสนุนที่เราต้องเริ่มที่จะต้องใช้Asphalt Pavement เก่านะก็คือพวกแรปที่กลับมาใช้ใหม่ในรูปของรีไซเคิลที่มากขึ้นนะซึ่งแนวทางที่เรานำเสนอในวันนี้เนี่ยก็จะเป็นเรื่องของแนวทางเทคโนโลยีที่เราจะใช้เรื่องของโคเทคนิคมาเป็นตัวนำนะครับผมขออนุญาตที่จะนำการนำเสนอตรงนี้พัดไปยังคุณซาเวียร์ซึ่งจะนำเรียนในภาคในรายละเอียดนะครับซาเวียร์ to start your presentation.
Thank you, Kunsuapan. Sawadee-kap. Good afternoon, everybody. So I will start my presentation about the low-carbon solutions for sustainable pavement. Okay, so you know that now one of the biggest challenges we have to face is the climate change and the increasing of the temperature in the world. So our industry and the road industry in general should face also this problem and find some solutions to decrease its carbon footprint impact on the climate and on the planet. That's why we have to find some low carbon footprint solutions. So what are these low carbon solutions? In fact, it will be products and techniques or process that will help to reduce the carbon impact of the road industry and the construction of roads. We have found now many ways to reduce this carbon footprint. The first one will be to deal with the binder and the impact of the bitumen. The second one will be to reduce the greenhouse gas emissions or the CO2 emission from our asphalt mixes. And the third one will be to promote the use of recycled materials. So I will develop all these three solutions during this session. So talking about the binders and the bitumen. So you all know that bitumen is coming from oil refineries, from non-renewable products. But now we have to find some solutions to find alternative binder and more sustainable binders. The first one is to find a carbon neutral bitumen. The thing is, by producing bitumen, you have the refining process generate a lot of heat and a lot of CO2 emission and greenhouse gas emission. So the carbon impact of a bitumen coming from fossil fuel is very high. So one of the trick is we know that the product which have a positive impact on the carbon footprints are products coming from the biomass, coming from vegetable, from trees. So all the deal will be how we can blend traditional bitumen from fossil fuel with product coming from biomass, which have a negative carbon footprint, to neutralize the carbon footprint of a bitumen. This is the first trick. The second one will be we have to check the compatibility and the miscibility of these vegetable or green additives with normal bitumen. So this is clearly an example of what we are looking for now, is that we know that we can measure the carbon footprint of a product in a kilogram of CO2 equivalent per ton. We know that after a life cycle analysis and depending on the crude oil origin, that bitumen can have a positive carbon footprint between 150 to 600 GWP. Bioadditives coming from biomass origin, so from tree or from vegetal, has a negative carbon footprint. So by blending these two products, we can neutralize the carbon footprint of the bitumen. Sorry, there is a microphone open. Thank you. And even if we increase the percentage of the bioadditive, we can have a negative carbon binder. With a... Now this product has already been developed by some companies where we blend some normal, or I would say traditional bitumen from fuel or from petrol with some vegetal resin. Depending on the additive used and depending on the penetration of the based bitumen, if you blend between 10 to 20% of this bioadditive with, for example, a 20-30 pen grade bitumen, you can obtain a 40-50 or 50-70 penetration grade bitumen. And the properties of a bitumen, so it means that it can work. And now the research and the next step on this product is to check the real property of this, we can say, modifying binder, because when you add this vegetal resin or this product from biomass, you will have to check if you meet all the specification and the requirement of the bitumen, especially viscosity, properties after aging, and the long-term performances also. So this is clearly still some research ongoing on this product, and also how we can use this carbon neutral bitumen in all the various uses we have in bitumen, in fact, with compatibility with hot or warm mix, with cold mix, emulsions, process, etc. If you push the logic of a zero carbon footprint binder, so now you can go at the ultimate step. It is to develop bitumen or binder coming exclusively from plants or from vegetal. This is what we have called biosource binder. And this binder is made from raw materials coming from exclusively from biomass and not from oil and petroleum. So this binder already exists. It has been developed in Europe for many years now. It acts as a carbon sink. In fact, the carbon footprint of the bitumen is negative because it's made for plants which absorb the CO2 from the atmosphere. This bitumen, what is interesting with this binder, not bitumen, is that this is a clear binder because you don't have a black component like the asphaltene we have in a normal bitumen. It's a translucent binder which can be used to highlight the natural color of aggregates, or we can be used for colored product. It has to be produced in dedicated plants because you have to blend the recipe, you have to blend some resin, some vegetable oils, some additive to obtain this biosource binder. It can be the equivalent of what the bio oil, biopetrol you put in your car. This one is clearly a 100% based plant binder. It has been used for very various applications, more for aesthetic surface in urban environment or in architectural sites. As it's a translucent and transparent binder, if you put some pigment, you can color also the mix. The performances of this binder are clearly equivalent to a standard bitumen. With regarding penetration, softening point, aging, and it also show a good resistance to hydrocarbons. The only not concern, but you have to be careful when you use this product because as it's a clear binder, you have to clean all the production, transport, and application equipment. It should be manufactured in a plant, or a traditional hot mix plant, but with dedicated pipes different from the black normal bitumen. You should not heat this binder, so it's also a warm mix. And it's preferable to use mechanical equipment for the laying. After, if we still continue to discuss of sustainable binders and from binder or product coming from biomass and from vegetal or from plant, we've got also in the range of product from prime coat and what we call bio-based prime coat. So you certainly know the traditional prime coat of EAP, emulsified asphalt prime we use in Thailand. So this prime coat, it's a traditional product to use on gravel road, to spray, to waterproof a surface, to allow traffic during construction, and to have clearly a better bonding between the gravel layer and the bituminous layers we put on the top. So the prime coats are generally so it's an emulsion product, so it's a blend of bitumen, water, and solvent. And generally, this solvent is a petroleum-based solvent. It's kerosene or diesel. So coming from, same thing, from the fuel and from petroleum and oil industry. Now, we have developed some prime coat product using solvent, not solvent, but fluxant, coming from vegetal and especially from vegetable oil. So this product has the same, even better performances and properties than the traditional prime coat made with kerosene or with petroleum solvent. It's clearly easy to use, it's the same process. The clearly advantages of this bio-based prime coat, it is non-flammable because you don't use petroleum solvent. So it's safer for the manufacturing, the production, the storage, the transportation, and also the spraying. And regarding the environment, you don't release COV in the atmosphere, and also you minimize the carbon emissions, and you have a very good carbon footprint of your product. When we evaluate this emulsion asphalt prime or this prime coat product bio-based in laboratory, so we use the same process and the same tests as we have used for a traditional prime coat, and so especially what we call the penetration power test, where you put some sand in a tube, and then you spray, you drop some emulsion or some product at the top of this sand, and you measure the penetration depth of the product and the time the product takes to penetrate in this standardized sand. As you can see on the picture in the lab, after 20 minutes, if we compare the normal traditional CSS1, so cationic stable slow setting emulsion, sorry, which we know doesn't penetrate very much and doesn't have a very good priming power. If we compare the prime bio-based and the prime standard, you can see in the middle the prime coat with bio-based solvent has a better penetration depth after 20 minutes than the standard priming, and obviously even better than the normal CSS. And what also is interesting with a bio-based prime coat product is that it will dry faster also. So you will be able to reopen to traffic faster, and you will obtain quicker your nice surface to reopen to traffic. So this is the 3 examples of what we call sustainable binders or alternative binder we can develop to replace or not to yes, it's a long-term process for sure, but it starts to be some ideas how to reduce the carbon footprint and the impact of traditional black bitumen coming from petroleum on the environment. So now, after talking about the binder, we will talking about the mixes, and especially we know our industry, flexible industry, so flexible pavement, we use hot mix asphalt. So by the definition of hot, it means that we have to heat our product, and especially the binder, to have a correct viscosity to coat the aggregate, to be able to have a workable product, be able to be spread and to be compacted on site on a nice layer. So we know that by heating the product, we consume some fuel and we release some greenhouse gas in the atmosphere. So all the topic now and the trick is to reduce the mix temperature of our product that we use in road construction and in pavement construction. But if you reduce the temperature, you should not degrade the property and of your mix. So you should keep, or at least even improve the properties of your product. So you see that reducing, so the purpose first will be to use what we call the warm mix. It's clearly not something new, something we have already developed maybe more than 10 years ago. But now, with all the environmental concern, it becomes more and more popular in a lot of countries. And the trend is clearly not to heat anymore at very high temperature of the product, but to progressively switch to warm mix asphalt. There is a lot of benefits. So for sure, you will reduce your energy consumptions. You will have less pollution because you release less greenhouse gas. For workers on the safety concern, it's better also to work behind the paver at a lower temperature than 160 or 170 degrees. You also decrease the bitumen aging during the production because you don't heat your binder at a very high temperature, so you don't degrade you don't degrade. You age less your binder when you manufacture your hot mix. So what I say, the only thing is that your warm mix asphalt should have the same performances as a hot mix. So you should have a good coating of your aggregates, and the final properties of your mix after laying and compaction should be exactly the same as hot mix asphalt. So it's what I say, it's an improved technology. It's clearly efficient. So by decreasing by 30 or 40 degrees your hot mix, you will also have a good effect and a positive effect on the fume emissions also on your mix. And there is a lot of studies saying that 50% less fumes for each 12 degrees drop of temperature. It can be interesting with some source of bitumen also, and you will reduce the emission and the around your project, your work site. Also, there is different type of technologies for warm mix, but the most used, I think, and most efficient is clearly to use some chemical additives to add in your bitumen, in your binder. So this liquid additive will helps you to reduce the mixing temperature by 30 to 40 degrees. So you can see the table at the bottom of my slide. For 60, 70 penetration grade bitumen, traditional grade we use in Thailand, the usual production temperature is between 150 to 160 degrees. With a warm mix additive in it, you will be able to reduce to 125, 135 your production temperature. And the 4050, so which has a usual production temperature higher than the 60-70 because harder grade, so higher, more viscous binder. The production temperature with additive will be around 140 degrees Celsius. So what is important to know is that these additives are, we call them surfactant. They have no effect on the viscosity of bitumen. I will show you after some laboratory results. It just help to reduce the frictions between the binder and the aggregate at the surface. So it helps, it's like a lubricant when you manufacture your mix in the hot mix plant. And it will clearly increase the workability of your mix, even at lower temperature. So when you will be able to compact, I would say, easier, and you will obtain a lower void content with binder with additive, with this chemical warm mix additive, than with a traditional hot mix. And it has also a double effect, which is very interesting. It's promote also the adhesion between the bitumen and the aggregate. So it has a double effect of warm mix additive and adhesion agent anti-stripping additive. So for with one product, you have two advantages. How you add and how you introduce this additive into the bitumen, it's quite easy, but you have several methods at the plant to inject this additive. You can inject in the bitumen line when you manufacture your mix, or you can add in the bitumen tank. So it's clearly two different processes depending on the equipment you have in your hot mix plant. And this product is validated for all type of hot mix asphalt, so all the conventional type, for base core, wiring cores, even for the hard grade, and even for PMA modified hot mix. And what is interesting is that the storage temperature, you can keep the product during 2 or 3 days, and it will keep its efficiency in the bitumen. So I was talking about laboratory study. The first one I want to show you just two main results is the bitumen viscosity with additive and without additive. You can see that we measure the viscosity at different temperature of a pure bitumen, a bitumen with say additive 1 and additive 2. We try two additives on the market at the same dosage. And there is absolutely no change of viscosity with this additive. But in the mix, when we use this bitumen with warm mix additive and we measure the properties of a hot mix asphalt compared to warm mix asphalt at different temperature, we can see what we will obtain better performances of the hot mix asphalt, of the warm mix asphalt compared to the hot mix. Because you will have a more dense, more workable product, lower void, and as what I say also, as it acts also as an adhesion agent, you improve the resistance also of your mix. So there is a lot of benefit to use with warm mix. You reduce the temperature, you consume less fuel also, so you have a reduction of the cost of your hot mix. You reduce the CO2 emissions, you reduce the smoke, the fume, and there is, as you manufacture, produce, lay and compact the mix at a lower temperature, you will be able to reopen to traffic also quicker. So there is also these advantages, and you improve clearly the densification of the mix. You improve the density of your mix with this type of additive. after warm mix, so warm mix, you are still above 100 degrees Celsius. It means that this is the point, if you remember the graph in my introduction, in fact, this is the 100 degrees is the point where you have to heat your aggregates to eliminate the water in your aggregates and your mix. So you have to be above 100 degrees if you want to have a correct, workable, and a good coating between your aggregates and your bitumen, hot or warm. If you are below 100 degrees, you change paradigm, you switch from the warm or hot technology to the cold technology. And the cold technology will be to manufacture mixes with emulsion. So emulsion, which is a blend of bitumen and water. So with emulsion, as you have water in the binder, you don't need to evaporate the water in your aggregate to have a correct coating. So this is completely another a change of technology. But cold mix is the ultimate product for a low carbon, it's a ultimate low carbon solutions, I would say, because you don't heat your aggregate, you don't heat your binder, you manufacture and you produce at ambient temperature. So you don't release greenhouse gas to produce to produce your product. Cold mix, there is a lot of definition of cold mix. It's what I said, despite the long background, there is no complete and satisfactory official definition of a cold mix asphalt, especially if you change country, continent. Everybody is talking about cold mix, but maybe sometimes from different products. What we can say is that a cold mix is a blend of aggregates with an emulsion. And after you have a lot of different type of cold mix. Here I will focus on cold mix for wearing course. Okay, and cold mix which cannot be stored. So you produce a cold mix, you transport and you lay. Okay, it's not a storable cold mix like we can see on the market in bags to repair pothole. Okay, it's not storable one. It's cold mix with a short life. And what is interesting in this cold mix, it is a dense cold mix. And you would see why the dense is important. So dense graded cold mix, in fact, is just to show you that generally the cold mix we find on the market and the cold mix we find for patching, for example, are open graded cold mix. So it's a single size aggregate which is coated by emulsion and put it back. So with a very high void content, 20%, generally around 20% of void in this mix. So it's quite workable, but durability and I would say the performances of this open graded cold mix are not very good or very satisfactory for long-term, for medium-term or long-term performances. So what we target here is to develop cold mix for wearing course and for, I would say, medium traffic, low to medium traffic pavements. So this cold mix should be dense, so with a sand fraction. So it's a blend of sand and coarse aggregates, highly workable with good performances, and with a low void content, I mean percentage of void less than 10%. The aggregates, so the composition of this cold mix, the aggregates should be not too big in the size, maximum 12.5 millimeters of half inch, and it should be very good quality aggregates with the same quality and characteristics and the aggregate we use for hot mixes. And then we will have the binder, so will be a bitumen emulsion, and generally it's a specific bitumen emulsion, specifically designed for the aggregate we will use, and we target a medium setting time. In fact, why? To have the time that the emulsion doesn't break when you mix with the aggregate. You need to have time to coat correctly your aggregate, and you need to keep the emulsion and the mix workable during the transportation time before you go on the site. So there is a mix design procedure to this cold mix asphalt. You have to identify your aggregate, good mix proportion to target a grading curve. Same emulsion depending on the bitumen you have, aggregate, the emulsifier. So you characterize and you design an emulsion. You blend. The first will be a coating visual appreciation. That it will check the affinity of the emulsion with the aggregate you have. And then you can make some performance tests, Marshall stability or more water resistance, so the TSR test. And as you can see, we have made some tests with an open gradient mix compared to a dense mix. And each time the dense mix, because of its low void content and also specific formulation of the emulsion, I would say, you achieve better performances of this cold mix than with an open dense cold mix than with an open gradient mix usually find on the market. All the trick with this dense mix and will be to have a good coating of your aggregates and to design a suitable emulsion which will not break immediately because you will have sand, so you will have fine in your mix. So it's necessary to design a very specific emulsion. For the production, what is nice and easy is you just have to use a small cold mix plant. It can be, you see the picture here, it can be small transportable cold mix plant where you have two uppers where you put your sand fraction, your coarse aggregate fraction, and you inject your emulsion in a mixer, and then your product is quite ready. Bitumen content, residual bitumen content, it's quite the same as a hot mix. And you can lay this product between 30 to 50 millimeter. And as you can see the picture, it's clearly a dense surface and a nice and smooth surface. And so it means that you will have a durable product and able to resist to traffic and to, yes, light traffic or even medium traffic. So this product is clearly used in a lot of countries, in a rural area or even on very specific project. It has to be laid clearly so at ambient temperature. So this is the advantage of this product, and it's laid with traditional equipment, paver or grader, and it has to be rolled and compacted with a traditional PTR or steel, sometimes steel roller, depending on the equipment you have on your site. So what I say is dedicated to private small project or project in remote area. If you have difficulties if you don't have a hot mix plant or if you have difficulties to supply material, you can transport the product during several hours. So it is quite interesting compared to hot mix asphalt where you produce your hot mix, the window to lay and to compact is generally narrow. So cold mix asphalt is a solution for that type of project. Now, the third type of solutions we have. So after discussing of acting on the binder, acting on the temperature of the mix, now it's to recycle. And we will know that by recycling, we will clearly reduce the impact of the works on the environment because we will use existing road, existing pavement, existing aggregates or binder mix which has been laid 10, 20 years ago. And by recycling, we don't use new products or new aggregates or new binders. So we save a lot of energy. We save a lot of greenhouse gas effect with that because we did not transport new binder, new aggregate. We don't use new product. So recycling solutions, it has already been developed today, but you clearly know that in the road construction, there is two main types of recycling, the in-plant recycling. When we mill a road and we use the mill material, what we call the wrap in new hot mix, and we blend this wrap in the hot mix plant. And on the other side, we've got the in-place recycling, the in-situ recycling. And I would differentiate two types of solution, what we call the FDR, the full depth recycling, and the cold in-place recycling. The full depth recycling is where we will recycle the existing pavement structure on full depth, so deeper than 150 millimeters or 200 millimeters. We are doing a structural refurbishment. We will clearly recycle a deep and a thick pavement. And generally, I would say the binder used for this type of full depth recycling is cement. Our cement has a very bad carbon footprint, even worse than the bitumen, because to manufacture cement, you have to heat at very high temperature. So it has very negative impact. So that's why what we want to privilege is the cold in place recycling. So it's clearly shallow recycling, so not very deep, less than 150 millimeters, so just the surface of the road. And when we make this cold in place recycling, we will generally use an additional binder to help to improve the recycling process, and this binder will be emulsion, and sometimes combined with a little bit of cement, but it's not mandatory. So I will develop this cold in press recycling process in the next slides. So it's what I explained. Clearly, the topic and the purpose of this cold in place recycling is to have an action on the top of layers of existing pavement. And these layers should be 100% or majority or old asphalt mix. So instead of milling, removing this hot mix, this old asphalt mix to be used in a plant as a wrap, we will reuse them on site. The problem of this old asphalt, you can see in the picture, is generally it's an edge binder. You have a lot of cracks. You can have pothole. You have alligator cracks, rotting. So the condition of this mix is in bad condition. Otherwise, we won't have to repair it. So with the machine, with a recycle machine, we will come and mill. And to improve the characteristic of the existing wrap, we will add specific emulsion. It's the same. Which will act as a regenerator, or not really a regenerator, as a new binder, and which will improve the characteristic of the existing roads and materials. And you can see all the train, recycling train here. Behind the recycle machine, what is nice is you will have clearly a ready to pave product. You will have to compact it, and you will have a new layer, a new binder course, which can be after overlay with a new wearing course. So more detailed recycling process. The machine with the integrated paving system. So this is what's nice, that you mill. Let's see if I can. Yes. You can see here the milling process. Then the existing wrap go on that conveyor, and then you inject emulsion and water, and then your new mix here is directly paved as a new layer, and then you just have to compact. Oops. Date clear. Up, yes. So before going into a cold in place recycling project, you will have some stuff to do and some laboratory study to perform before. And there is clearly a methodology to follow. There is a lot of guide now, technical guide dealing with the cold in place recycling project, especially in the US, in Europe, Australia, South Africa, and the methodology is almost quite the same for all these countries. First, you will have to make a site survey. What is the condition of the existing road? What is the thickness of the existing pavement, and how many millimeter of hot mix I can recycle? Then to take some sample of this mixture and to analyze in lab. So the sieve analysis for sure, the binder content, the clay content, if we have a clean product or not, because it will have an influence on the emulsion formulation and emulsion design. Then you will have to find the optimum emulsion formulation with the correct emulsifier to have a good coating of your existing product, and the optimum emulsion content will have to be designed in lab according to performance tests. So you will compact specimen in a Marshall mold, cure them, and generally we make two types of tests: is a UCS, so an unconfined compressive strength, or an ITS. And this is just after this test that we make the final design of the mixture. So this is an example of case study we have done on a cold in press recycling project. And with usual spec, so what I said, depending of the country where you are, or depending of the project, some consultant, they will give you some specification regarding the compressive strength, regarding the deformation, or the ITS value. But this is the traditional value we find in the guide. So what we target, for sure, it's a good TSR, so retain strength after immersion, a good dry ITS, and some compressing strength, yes, between around 2 megapascal. This picture just to show you the process on site. So first will be the milling and the mixing. It's what I said, depending on the machine you have. Some machine will don't have an integrated paver, so you will have to use a motor grader. Some machine have an integrated screed at the bottom, so you don't need a grader, and you can directly compact your mill material, your in-place material. Then you will have a curing time, because with the emulsion, we'll have to set and to cure. So generally, you protect, if you want to reopen to traffic your layer, you will have to protect it with a cure coat, with a coating. So generally, it's a prime coat, or it's a single CRS or a CSS prime coat and a chip. And after curing, you can pave with a new varying course. And the new varying course, depending on the project, depending on the traffic, could be a micro surfacing, could be a thin asphalt varying course, or a thick asphalt varying course. So these techniques of cold in place recycling, compared to the traditional solution you have by milling and filling, even if you reuse the wrap in the new hot mix, it's clearly cheaper than the traditional mill and fill, because you don't have all the transportations of a mill product. You reuse everything is used in place. The only new materials I would say import, you bring to the project is the emulsion and some water. So you reuse all the materials in place. So you make some saving on purchase, on excavation, on number of truck, all like that. So clearly, for a contractor and for the owner, it's clearly a cost-effective solution and a cheaper solution. Regarding the environment, you reduce your greenhouse gas emission, your fuel consumptions, because you have less machine, less transportation. This is an example of calculation of life cycle analysis. So it's a software, it's what we call the Sieve software. It's a life cycle analysis. It's a software developed in Europe where you can assess all the greenhouse gas and energy consumption of a project from the extraction of the materials to the implementation and the laying. And you take into account all the stages of your project, all the energy you will use, and all the CO2 that you will emit during the project. If we make a calculation of when we call the traditional, so mill and fill project, so where you mill, you evacuate your wrap, you bring new material, you pave hot generally. If you compare with a cold in place recycling, clearly you reduce your CO2 emission almost by half. This is an example on a specific project. If you take another project, it can be 30% or 35%, but clearly there is a reduction of the greenhouse gas emissions. So we are in the low carbon, so 100% in the low carbon solution. If we continue of all the advantages of the cold in place recycling technique, so you reuse 100% of existing materials. So this is a fully recycled project. You can reopen to traffic. So during time and delay, shorter time for completing a project, generally shorter than a traditional solution. And at the end, you have structural values, structures similar to what we can have with hot mix. And as it's a cold process, also you increase the safety of the crew and everything. These technologies and these processes are clearly now the trend in a lot of countries because you save time, you save money, and you are clearly in this sustainable policy in roads construction. So to conclude, this is the end. Yes, in the time. So clearly now, what we focus, so in TIPCO Asphalt, in Colas Group, and everywhere in the world, is that innovation must be clearly driven by the promotion of sustainable solutions. We have no choice. It's now, and it is also the duty of a road construction company and all the people working in this industry. So the three main solution and research acts we have now is clearly to find alternative source for binder. Okay, we know that one day it will be more and more difficult to have access to crude oil, so we have to find alternative source of binder to build our roads. We have clearly to promote solutions and with production temperature at lower level. So we have to reduce our energy consumption and we have to produce with lower energy. And as we know, and that is not as well known by the public, I think, is that asphalt is clearly a material that can be 100% recyclable. It's not the case of a lot of materials in the industry, but yes, we know that we can recycle asphalt 100%, and we have a lot of solutions how to recycle this asphalt. So as former President Obama says, if you want to prevent the worst effects of climate change before it's too late, the time is to act is now. Thank you for your attention.
ค่ะ
ถามได้เลยไหมครับ
ค่ะ
ถามได้เลยครับขอบคุณครับ
ครับ
ผมครับ
จะถามว่าไอ้ตัวสวัสดีครับสวัสดีครับ
สวัสดีครับ
ไอ้คาร์บอนซิงค์อะไร
ท่าน
เนี่
เข้
ย
มาสวัสดีครับ
ครับคาร์บอนซิงค์เนี่ยเวลาไปใส่ในฮอตมิกแล้วอุณหภูมิมันลดลงใช่ไหมครับอุณหภูมิ
นี่นะ
เอาไปใส่แล้วทำให้อุณหภูมิฮอตมิกลดลงใช่ไหมครับ
คาร์บอนซิงค์ใช่ไหมฮะXavier
Yes.
The director from asked about the carbon sink.
Carbon footprint of
No, carbon sink.
carbon fin.
Carbon
ซิง
sink.
อะไรที่ผมจำไม่ได้ว่ามันอยู่ใน PowerPoint อ่ะ
They're talking about the bioadditive. Talking
Yes.
about the intensity of the carbon, and they ask that if we put the carbon sink into the asphalt mix, the temperature is higher or lower?
Lower.
It will be a little bit lower, yeah. After it's what I say. With the bioadditive, if we put to obtain this carbon neutral bitumen, so the additive will have an impact on the viscosity, for sure, on the bitumen. So and it will decrease the viscosity. So yes, you will have a different temperature range with this added. With bio binder, I would say than a traditional bitumen. Yes.
ท่านแปลหน่อยครับ
ก็ใส่ก็อย่างที่เขาบอกถ้าใส่แล้วอุณหภูมิจะลดลงเล็กน้อยก็ไม่ได้มากครับ
ครับ แล้วไอ้ product ที่2คือเอาไปทำในงานพามโค้ดใช่ไหมครับ
ขออนุญาตนิดนึงเมื่อกี้ตัวเรื่องของในแง่ของท็อปิกแรกเรื่องของ intensity of carbon เนี่ยเรามี product 2 ตัวตอนนี้ที่ตัวแรกนี่คือตัว asphalt cement grade penetration grade นะครับที่เราพยายามจะเอาลดเปอร์เซ็นต์คาร์บอนในตัว asphalt ลงโดยการใช้พวก bioadditive ตอนนี้อยู่ในระดับ scale research อยู่ก็คือจะลดตัวเปอร์เซ็นต์คาร์บอนซึ่งปกติคาร์บอนที่อยู่ใน asphalt cement เนี่ยมีประมาณ 80%เราพยายามลดลงเพื่อไปสู่ทิศทางของ sustainable อันที่2เนี่ยตัว emulsion เนี่ยเราพัฒนาใน lab scale ตอนนี้คือเราจะปกติแล้ว emulsion ที่ทำพรามโค้ดเนี่ยยังไงก็ต้องมีน้ำมันเป็นตัวที่เข้าไปในส่วนในการผลิตแต่น้ำมันที่เราใช้นั้นเป็นน้ำมันทั่วไปเป็นน้ำมันเป็นปิโตรเลียมเกรดนะฮะเรากำลังทำรีเสิร์ชเพื่อเอาพวก vegetable oil มาใช้ในพรามโค้ด EAP นะซึ่งตอนนี้เนี่ยขั้นตอนแรกที่เราทำและลองทำเป็น Additive Power เนี่ยมันออกมาค่อนข้างจะดีการแห้งตัวก็ดีกว่าครับ
ลึกกว่าแล้วก็แห้งเร็วกว่า
ครับแต่ว่าตอนนี้ปัญหาคือต้องดูว่าคอสมันจะเพิ่มขึ้นเท่าไหร่เพราะว่าพวกvegetable oil เนี่ยมันก็มีราคาแต่ว่าเป้าหมายของเราคือทำสินค้าที่มันลดผลกระทบด้านสิ่งแวดล้อมพวกนี้ลงแล้วก็ลดการใช้พวกยางมะตอยมาเป็นเพราะว่าพามโค้ดเนี่ยต้องใช้บิทูเมนหรือแอสฟัลต์ซีเมนต์ประมาณ50-60%นะครับในการผลิตครับ
ก็และโคมิกนะโคมิกที่พูดไปนั้นน่ะมันใช้เวลาสามารถที่จะขนส่งไปได้นานแค่ไหน
โคมิกที่เป็นเรดดี้มิกเนี่ยถ้าตอนที่ทำรีเสิร์ชนี่ประมาณ96 ชั่วโมงครับก็คือ
ที่มิกจากแพนแล้วใส่รถออกไปหน้างานนะหรือว่ามันเวลามันสั้นนะ
ใช่ครับมันก็แค่คือในการผลิตประมาณ96 ชั่วโมงแล้วก็ต้องใช้ภายใน96 ชั่วโมงครับถ้าดูตามที่เรา
ว่าประมาณเท่าไหร่กี่วัน2 วัน 3 วัน
2 วัน 3 วันครับแต่ก็จริงๆ2 วัน 3 วันนี่ถ้าในแง่การทำงานเนี่ยถ้าเป็นลักษณะของเรดดี้มิกเนี่ยมันก็เราก็คงทำก่อนหน้า 2-3 วันอยู่แล้ว
อันนี้คือมิกจากแพลนใส่รถบรรทุกออกไปคุมผ้าใบออกไป
เหมือนกับว่ามิกแพลนทั่วไปอะครับก็คุมผ้าใบแค่ไม่ได้เรื่องป้องกันความร้อนแบบว่าป้องกันการปนเปื้อนมากกว่าการคุมผ้าใบคงไม่คือเราวัตถุประสงค์กันครับ
วันนี้จะดูไอ้รูปกราฟของวอร์มมิกเนี่ยจะถามว่าไอ้น้ำมันที่ใช้ไอ้ตัวนั้นน่ะมันเป็นน้ำมันเตาเอหรือเปล่า
ไม่ใช่ครับคือในเรื่องของวอร์มมิกเนี่ยทางที่ว่าเรานำเสนอในแง่ของการพรีเบรนด์นะครับเราใช้ Additive เติมเป็นวอร์มมิก Additive
แต่ในกราฟนั้นมันกราฟมานานแล้วไอ้กราฟวอร์มิกตัวนั้นมันกราฟมานานแล้วนั่นนะ
กราฟนานแล้วครับ
อืม
เพียงแต่ว่าเทคโนโลยีของวอร์มิกมันน่าจะมีเยอะครับท่าน
ครับ
จะใช้แบบเป็น additive หรือจะเป็นพวกsurfactant ก็ได้หรือจะเป็นพวกโพสเบนก็แล้วแต่ครับแต่ว่าที่ของที่ไวฟ้าเลยนำเสนอเรื่องของเติม additive ในลักษณะของ pre-blend ครับ
ที่เป็นก็คือใส่มาในยางก่อน
ใส่ในยางมะตอยครับแล้วมันก็มีข้อจำกัดเรื่องของสวิตไลท์ของมันนะครับใช้เวลาก็ไม่นานนะที่มันจะคงสถานการณ์เป็นวอร์มิกอยู่ครับ
ครับก็เก็บไว้ไม่ได้นาน
ใช่ครับก็เสียมันก็เก็บไว้ไม่ได้นานครับ
ครับแล้วตัวเดี๋ยวนะวอร์มิกอันนั้นก็เอามาใช้บ้างหรือยังในประเทศไทยเคยมาใช้แปลงทดสอบไหม
จริงน่าจะเคยทำpilot project ไปแต่หลายปีแล้วนะครับ
หลายปีแล้วตอนโน้นนะตอนโน้น
ใช่ทำ pilot project โดยใช้ผมเข้าใจว่ามีทำหลายโปรเจกต์นะมีทั้งวอลมิกที่เป็นพวกพรีเบนแล้วก็โพสเบน
ครับ
ถามได้ไหมคะรบกวนพอจะถามคำถามได้ไหมเอ่ยสวัสดีค่ะถามคุณสมาคมนะคะ
ครับ
ตานจากโซลาร์ฟันนะคะเมื่อกี้สนใจที่บอกเกี่ยวกับวอลมิกที่ทำ pilot project ในประเทศไทยอะค่ะเคสที่ในกรณีเป็นพรีเบนนะคะอยากทราบว่าพอปูไปแล้วเนี่ยค่ะวัดผลแล้วประสิทธิภาพเป็นยังไงคะถ้าเทียบกันกับการปูแอสฟอติกปกติ
ก็จริงๆตอนที่เราทำ pilot project เข้าใจว่าตอนนั้นทำที่จังหวัดตรังนะจังหวัดตรังครับภาคใต้ก็แผนตอนนั้นที่เราได้คือเรื่องอุณหภูมิแน่นอนครับเพราะว่าปกติแล้วฮอตมิกทั่วไปเราก็มิกอยู่ที่ประมาณ165ที่เราทำวอร์มิกตอนนั้นเรามิกอยู่ประมาณ135-140นั่นก็คืออุณหภูมิของการมิกเนี่ยลดลงประมาณ30-35 องศาเลยแล้วก็ประเด็นที่สองคือตอนนั้นเราทาร์เก็ตสายทางที่จะทำเนี่ยระยะทางจากแผ่นที่จังหวัดกระบี่ไปจังหวัดตรังเนี่ย100 กว่าโลครับผมจำตัวเลขไม่ได้ว่า130-140ซึ่งก็ไม่มีผลต่ออุณหภูมิแต่ว่ายังแนะนำให้มีการปิดผ้าใบเพื่อควบคุมอุณหภูมินะแต่ว่าอุณหภูมิที่ออกจากแผ่นใบเนี่ยก็ประมาณ135-140เนี่ยนะประมาณนี้ไปถึงหน้างานก็มา110-120ก็ยังสามารถทำงานได้
คือคอมแพคได้ปกติไม่มีปัญหา
ปกติเลยครับผม
แล้วในกรณีที่พรีเบรนนะคะตัวพรีเบรนเข้าไปนี่ไลฟ์ไทม์ที่มันอยู่ในตัวยางเนี่ยค่ะมันใช้เวลากี่ชั่วโมงค่ะหรือว่ากี่วันกว่าที่มันจะคืนสภาพตัววอร์มิกซ์อะค่ะ
ตอนนั้นที่ทำเนี่ยยิ่งต้องเรียนว่าAdditive ที่เป็นตัวพรีเบนเนี่ยพรีเบน Additive มันมีหลายตัวนะแต่เราใช้ Chemical Additive นั้นซึ่งข้อจำกัดมันคือเรื่องเวลามันจะมีอายุของการใช้งานอยู่ประมาณสัก72-96 ชั่วโมงคือประมาณ
คือมิกเสร็จต้องรีบใช้ก็ต้องรีบผสมเลยเข้าแพลนเลยถูกเข้าใจถูกไหมคะคือสตอเรจไม่ได้
ตัวไบเดอร์ครับตัวไบเดอร์ที่อยู่ในใช่ครับใช่เขาต้องเรียนนานๆเราหมายถึงไบเดอร์ที่เป็นยางมะตอยที่อยู่ในถังนะครับที่เราผลิตที่โรงงานแล้วขนไปไว้ในถังที่ฮอตมิกแพลนนะครับเนี่ยต้องเวลาในการจัดเก็บเนี่ยประมาณ96 ชั่วโมงแต่จริงๆในเทคโนโลยีสมัยใหม่เนี่ยมันมีพวกAdditive ที่มีอายุถึง7 วันwe are sorry talking about the additive in the
Vomix. Yeah, understood.
I talk to you later.
I'm just not sure about the lifetime of the additive for the pigment at fault. I don't know how long it takes or it lasts, how many hours.
You mean hour? It's what I say. It's few days.
2 days. So 48 hours.
Few days. So it generally it's what I say, depending on the injection method. If you inject online when you produce your hot mix, you don't have an issue of storability or efficiency. If you put the additive in your bitumen tank and you keep your binder under storage during 1 week or 2 weeks, for sure at the end of 2 weeks, the additive won't be efficient anymore. But what we observed is 3 days, 100% sure that after 3 days you can reuse. More, it will depend on the temperature of storage and your type of bitumen. But we can say 1 week, it's the maximum with no risk.